Now, what we're going to take a look at today is the Alfa Networks dual band panel antenna. It's dual band for 2.4 gigahertz and 5 gigahertz, and it's the APA M25. Now, I have had one of these hooked up to my home network now for quite a few. It's probably getting on for 5, maybe even 6 years. And I have internet in the garden here at my home. And supplying that internet to the garden is just one of these. And it supplies a really strong 5 gigahertz and 2.4 gigahertz connection to all the areas of my garden. It's it's got a wide beam width, this panel antenna, and I've been really pleased with it. I get good speeds, to say it's hooked up to a repeater, and a really good strong signal in the garden. So I have had people asking about this particular antenna now for some time. I've never taken one of these apart, so I'm not quite sure what is on the inside here, but people have been using these apparently for the remote control on their quadcopter. I'm not sure which one, but I've seen some pictures online where people have got 2 of these hooked up, and one of the, in fact, let me get one. So here we are. As I said, I've seen a few pictures online where people have got 2 of these hooked up to their remote control. I think it's one with the built-in screen for the FPV, and one of these, and I think that's to power the 2.4 gigahertz Wi-Fi that the remote controller uses. But I hope they're not using one of these for the 5.8 gigahertz, because it's not going to work too well, or at least I think it's not going to work too well. Depends on the beam width, the bandwidth of one of these. But we'll hook it up to the network analyzer to take a look, because this is only designed for the 2.4 gigahertz and 5 gigahertz bands. So, you know, I don't think it's going to work too well at 5.8 gigahertz, but I put the picture up on the screen already, so, you know, comments below if you think that's what they are doing. I'm not sure, you know, as a lot of you already know, I don't fly quadcopters, so I'm not sure the bands that that particular remote control unit works at, but basically, you know, if you're trying to use one of these for 5.8 gigahertz, I think you're going to be a little bit disappointed. So I picked this one up off of eBay. I think I paid about £13 for it and a couple of pounds shipping. You can get these a little bit cheaper that don't have the Alfa Networks brand on them. There's a few sellers on there selling the plain black ones for a little bit cheaper, but it's supposed to be all the same on the inside. And as I say, I've never taken a look on the inside of one of these before, so I think we're going to have to get a spudger in between here and try and pry them apart. Hopefully there is no glue holding these together, but you never know. So now we've got the case open. Initial thoughts on this is not what I expected. It looks rather much like a dipole arrangement here, and we've got the same pattern on the back as well. I've already gone ahead with the continuity tester, and we're not shorted out on the ground and the signal here, so our coax isn't shorted out. But I can't see, what I can see here is the outer braid ground soldered on here, and then you know, the inner core signal soldered there, but I can't see that these elements are split in half in any way. But I'm not sure at the minute. I'm going to have to desolder this, and then we can measure the elements as well, just to see if there's any difference in the measurement, whether they're getting the dual band 2.4 and 5 gigahertz, because you know, some of these elements are just slightly smaller and differing in the measurements, or just the fact that you know, it's just a wide broadband antenna. I don't know. But something else I've already come across on some forums as well is people modifying these, and if we take a look at this back reflector here, it's not grounded in any way. It's just some aluminium tape in there. We see this a lot with the cheap Chinese panel antennas that we've taken a look at a few times in the past. I've got one just up here, but I've removed its back in there, but the aluminium tape is something we see a lot, so I wouldn't have expected to see it in the Alphas, but at least they've gone to the trouble of cutting it out properly and not some of the you know, the bad workmanship of some of the ones we've seen in the past from China. But this is the modification that I've come across on the forums, where people have made a copper backing for this to achieve a little bit more forward gain. Now, that's nothing new. We used to do something similar with these ones back in the day, but I've always found that it doesn't make any difference that I can see, and it kind of acted more as a placebo effect, people thinking you know, they were getting a bit more power out of it, but I've never seen any real difference in doing that. But I think what we can do is take this over to the network analyzer, have a look at it on there, and then I can set up a small experiment, you know, just to try that out. I'll make a copper back for this and we'll give it a test and see if it does do anything to the forward gain, because remember, this isn't grounded in any way, and it's not going to have a major effect if we use some thicker material. I think that'll be more interesting than doing a Wi-Fi scan, because we do know this is a damn good antenna, and as I said, I've used one now for quite a number of years and I'm pretty pleased with it, and it's from Alfa Networks, so it's bound to work well. But let me desolder this and we'll have a look at the measurements and just see if there's a slight difference in the size of these elements in here. But just looking at it, I can't see any real difference in that size. So I've gone ahead and removed this, and I've cleaned this solder pad up here as well, just to try and determine where that's connected, and there's no continuity between this and that point there, so I'm not sure whether this is the grounding elements here, and then this one at the top is you know, the active element, and the same with these here, because this on the back just seems it's connected through this point here, and these are all connected together, just looking, you know, through the solder mask there. So I'm going to scrape a little bit of solder mask away in the moment and just probe around with the multimeter for continuity. But you can see the elements here, it is orientated this way up, so your active elements are here and here and here and here, and then if we flip it over, then you know, they're opposites on this side. So we've got active elements here and here and here and here, so you know, it's going to produce a really good radiation pattern. I'm not sure what the front to back ratio is of this, with it only having this aluminium foil in here. I don't think it says on the box, but I think I've forgotten to mention that this is the gain of 8 dB for 2.4 gigahertz and 10 dB for the 5 gigahertz, so you get that little bit extra with the 5 gigahertz there. But let me scrape some of this solder mask off here, just so you know, we can get an idea if this is ground plane or not. So that's a mystery solved then, now that I've scraped away the solder mask. Basically all the elements on this side, which is the front facing side of the antenna, so that's its active side with its logo on there, all the elements on this side are ground plane, and then all the elements on the opposite side are the active elements, so they are separated, and this via that goes through here is isolated from this side, so I'm going to have to be careful soldering it back, but it's got plenty of solder mask around there, so I don't think I'm going to have any problems with that. So this is definitely a dipole arrangement then. We've got dipoles here and here, and these are the ground, and then we've got the dipoles on the back here that are the active signal parts of the dipole. So certainly is a you know, a dipole arrangement on that PCB. Now I'm measuring these elements and I'm getting around 19.8 millimeters. I think you know, if I got in there properly, it'd be around 20 millimeters, and you probably say, you know, that is not for 2.4 gigahertz and too long for 5 gigahertz, but you've got to take into consideration these tabs here. So now that we know this is a dipole type arrangement, these will be acting as balance and making the antenna capacitive and because these are a lot wider as well at these points than the feed lines, it will be extremely broadband. It's much like the dual band dipole antenna that I've shown in the past. In fact, let me just get one. So this one here, this is a dual band little dipole antenna, about 3 dB of gain for 5 GHz Wi-Fi and 2.4 GHz. So you can see that we've got these two tubes here, and it's a lot thicker than how you would normally build one of these. This is a 2.4 GHz dipole here, and you can see we've just got a piece of wire sticking out of the top. So they get you know, the extra broadband to cover the larger range of the spectrum by using this thicker tubing. Also, the measurements are a little bit different to take into account that thicker tubing. So if I bring my calipers into here, and if we you know, take off a millimeter or so for the heat shrink tubing there, you can see it's about 22 millimeters long, which isn't 100 miles away from the measurements that we have got here. I mean, these ones are a little bit shorter, but as I've already said, we've got these tabs here, and that will be adding a little bit of capacitance to this design, and because it's a capacitive antenna, then the measurements are going to be that little bit shorter as well. And as far as the driven elements, the distance from that back reflector, you can see there it's about 13 millimeters. I would tend to aim for about 14 millimeters, but it's definitely in the ballpark there of constructive and deconstructive waves. I mean, that's the thing you're looking for there, and there are many different distances where you know, you'd be in that range of a constructive wave. That's why you can have them much closer together sometimes on panel antennas. And somebody messaged me recently asking how you go about working that out, and it's just something that I know the information is available online. To truly understand something like that, you need a deep understanding of calculus, you know, if you wanted to work that out for yourself at different frequencies, you know, different mediums as well, I suppose. But you know, 13 millimeters, I'd tend to aim for 14, but it's definitely in the ballpark. So I've got the Alfa antenna set up on the bench here on the test rig. Just a simple setup, as you've seen me you know, do in many videos previously. So let's have a look at the output on the network analyzer. So taking a look at the output, then, I have to say it's a very, very nice waveform. The range of operation at 2.4 gigahertz is very narrow. You can see this very narrow dip just here where it performs at its best, and it's bang on 2.447 gigahertz. And you've probably heard me say many times in videos before, I try to aim for around 2.45 gigahertz for 2.4 gigahertz Wi-Fi, because that's kind of in the middle of the band of most routers, round about channel 6, and this is bang on you know, at 2.447, almost 2.45 gigahertz. And if we just go a little bit in each direction, you can see how narrow that dip actually is. So it's going to perform really well as a antenna for 2.4 gigahertz. But let's take a look now at 5 gigahertz just to see how well it performs at 5 gigahertz, because that's why most people buy this, because it's a dual band antenna. So the setup is exactly the same. I haven't changed anything with the setup at all I've done is change the frequency on the network analyzer, and look at that output at 5 gigahertz Wi-Fi. It's bang on right at the beginning of 5 gigahertz. Now, most Wi-Fi routers, you can extend the band coverage at 5 gigahertz quite lengthy, a lot more lengthy than you can for 2.4 gigahertz, but most just stay centered right at the beginning of the 5 gigahertz band, you know, as a setting on most routers, and most people just don't touch it. But this is really responsive, bang on at 5 gigahertz. You can see it there at 5.095 gigahertz. That's bang on at the start of you know, the band. So it's going to work really well, you know, just as well at 5 gigahertz as it does at 2.4. And you know, the response here compared to the both is absolutely phenomenal. I've taken a look at dual band antennas before, and you either have something that's really good at 2.4 and really poor at 5 GHz, or really good at 5 GHz and really poor at 2.4. But here, as we can see, it's really good at both of them frequencies. It certainly is outstanding. And I'm going to move the cursor now, because one of the things, I think I mentioned it before when we were looking at this, is I'm seeing photos of people using this on quadcopters and FPV, and I wasn't sure whether they were using it at the 2.4 GHz band or just trying to use it at 5.8 and get away with it. I don't know. But if I move the cursor along, it's also really responsive at 5.8 GHz. So I'll move the cursor along right to the end of this band, down into this dip here, and let me take a closer look. That's centered on 5.865 GHz, so it is going to work in the majority of the 5.8 GHz band that people use for FPV, and I'm just totally astonished at how good that is. It's got a dip as deep as the 5 GHz dip, and certainly as deep as the 2.4 GHz dip. I've never seen a dual band antenna, well, this is a tri-band antenna really, although it's not advertised as a 5.8 GHz antenna. You can see here on the output of the network analyzer, it's going to work just as well at that 5.8 GHz. You can set your little transmitter to be on, the opposite side of 5.8 GHz, and it's going to work really well. It's going to work really well at 5 GHz Wi-Fi, and it's going to work really well at 2.4 GHz. Of all the antennas I've looked at over the years, I really have not seen one like this that will perform at all three bands and perform just as well at all three bands. It's truly an amazing antenna. So the second test that I want to do is a test to see if the popular modification for this antenna does actually do anything, and that particular modification is adding an extra reflector there on the back of this Alfa antenna, whether it be a piece of copper, a piece of tin, or even aluminium tape, whether it increases the performance of the antenna or not. So I've just got a simple setup here on the bench. I've got a 2.4 GHz panel antenna there, single panel antenna, and at the minute I'm feeding RF into that. I mean, the amount of RF I'm feeding in doesn't matter so much, because we're going to do the same for both tests. But you can see the power output on there. The Alfa antenna is connected up to the power meter, and at the moment it's fluctuating around minus 9.567 dBm. So we'll do the modification, and if the modification works, we should see that drop down. We should see, possibly minus 8 dBm, for instance, if the modification works. So as you can see, I've ended up making a reflector out of some brass. I did first make one out of copper, but I've misplaced it somewhere. But this brass one fits a little bit better. The copper one wasn't quite as wide. But let's put this back together then and see if adding that reflector does improve the the gain of this antenna. So we've done the modification then, and I've got it hooked up in exactly the same way as the test without the modification, and if we zoom in on the screen there, you can see virtually no difference. I mean, if anything, it's jumping into the minus 10. So remember, if it did work to improve things, it would be lower than minus 9.5 dB, 9.7 dB, but you can see there it's made things a little bit worse. Now, I was a little bit intrigued to know why it performed worse with that modification, because with a better reflector you'd expect it to do a little bit better. Although the reflector isn't grounded, I would still expect it to do a little bit better. But I've hooked it up back to the network analyzer, and if we take a look at the display, you can see that the output on the network analyzer is now pretty poor compared to the first test without that reflector modification. You can see that dip there, which we had before, is nowhere near as pronounced, You know, it's I would say that's a pretty poor response for 2.4 gigahertz. And we've got this big spike here now, which we didn't have before. So possibly that reflector modification is causing some kind of spiking going off inside the antenna, but it's certainly completely changed the characteristics of this antenna, and it's now all out of whack for the 2.4 gigahertz anyway. And we've now got this dip down here, and that's at 2.3 2.397 gigahertz. So yeah, maybe doing that modification is not so much of a good idea. So I've just gone back and had a look at the box, and it does state on the box that it works up to 5.87 gigahertz, and as we saw on the network analyzer, it certainly does. It also states that it starts working at 5.180 gigahertz, but as we saw on the network analyzer, it's a little bit lower than that. And you know, I mean, they have better equipment than I do, of course, but we were getting a much lower, slightly lower frequency response than 5.1, and the 2.4 to 2.5 gigahertz, we weren't seeing it as wide as that. It was much more narrow, but still worked spot on for 2.4 gigahertz Wi-Fi. So I have to say, this is probably the first one that I've had in here to test that is truly a if not a dual band antenna, a tri-band antenna. Some of them that we've had in do claim to work up to, say, between 5 gigahertz Wi-Fi and up to 5.8 gigahertz for FPV, but when we've hooked them up to the network analyzer, they don't quite work that well up at the higher frequencies, or it works well at 5.8 gigahertz but then not works quite so well for 5 gigahertz Wi-Fi. But this truly is an outstanding antenna, and it's not that expensive either. You know, I picked this up for around £13-14 off eBay, and a couple of pounds for shipping, and you can get it a little bit cheaper than that if you look around on eBay. Now, as for modifying this with a more substantial reflector, like people have claimed on the forums and etc., that they've got more range out of this, as you saw in the test, it completely knocks it off center frequency, at least for the 2.4 gigahertz anyway, and I don't see any reason why it wouldn't for the 5 gigahertz frequencies. So I just completely stay away from this. This has obviously been designed and tested. You know, Alfa are a pretty good company when it comes to making this stuff, and they've designed and tested it with what looks like at first sight some cheap aluminium tape, but obviously it does the job, because this is just such an outstanding all-round antenna. So I hope you found this video interesting. It's really been an insightful video when it comes to looking at this antenna, just how good it is. Any comments or questions, drop them below. I mean, even if you've done this modification and you're completely sold on the fact that it does increase range, then let us know. But at first sight, from the test I did on the bench, and I've done that test many times, and it just doesn't seem to do anything as far as extra power goes, extra gain, but it does knock it off center frequency. So if you did enjoy the video, please give it a thumbs up, comments and questions, drop them below, and hopefully you'll join me on the next one.